Chris asked me to come and report on some recently completed research, and so I'm going to be talking about some lab, but mostly field research with Blatta species cockroaches. So these are the large, we call them the large scary cockroaches. Around here, it's probably unlikely you're going to see species within this genus. Maybe on the east side of the peninsula, you might get Oriental cockroaches. I'm not sure. I haven't seen this genus in San Francisco, but very, very common in most of California, especially warmer areas. And these cockroaches live outside, and what happens is they tend to get into structures. So, you're inside, you can see that there's a gap under the door, and for cockroaches, that's a superhighway to gain access to, inside space. And they don't really live and breed there, but certainly if people see them inside, they're big and scary, right? So they do tend to drive pesticide applications indoors. And so this program was an attempt to design baiting for these cockroaches where they live and breed, which is outside. So you guys may be wondering, who's this guy? Some of you I know, but I am the urban IPM advisor for the San Francisco Bay Area. That's a new position relatively for cooperative extension. We have a long history working with agriculture, but we are starting to work with a lot of urban clientele. And the goals of my program are really to reduce unnecessary pesticide applications, and a lot of those are associated with surface water concerns. We have increasing regulations at the state level on a lot of the insecticides, especially that we're using for structural pests, and it's because these materials adsorb or sit on the impervious surfaces. And whenever we have a storm event or somebody's hosing down their driveway, those materials get into the storm drain system, they get into our urban surface waters, and around here they get into the bay. So we're trying to reduce those kinds of contamination events. And then I'm working with the industry, and so I'm talking about the structural pest control industry, folks who are providing services not only to residents, but institutions, commercial kitchens, municipalities, to really help them evolve. They have a lot of demands, regulatory demands kind of limiting what they can do. They have consumer demands kind of requesting certain services, and they're going to need to evolve, and it's a process. And it's actually been a lot of fun the past 7 years that I've been working in this program. I'm highlighting two active projects. So bed bugs on the left, I'm working to develop educational materials for bed bugs in multi-unit housing. There's some new legislation that's relevant for folks there. And then subterranean termites. We're doing work with bait station systems, again, to move away from these liquid termiticides, which have been the mainstay for decades. This is more of the same here. Mission statement, let's develop new and evaluate existing IPM programs for key urban pests. As an IPM advisor, I always include a little bit of IPM dogma in my talks. IPM is a decision-making process. It doesn't mean that we're not using pesticides. It doesn't mean that we're choosing pesticide A over pesticide B, although I know that there's a component here in San Francisco that is interested in that. But before you get to that point where you're selecting a pesticide for pest management, there are all of these steps, okay? And I hope that even if we are using approved pesticide lists, we're working through the steps. So that means you're learning about the pest. You really have to understand the biology and ecology in order to design effective programs. You're preventing the pest. If you are taking my test later, prevention comes before all other management tactics in IPM. That's true, all right? And you're monitoring. So you have to have some way to know if the pest is present or absent. It's a hallmark of IPM, whether you're in agriculture or urban systems. A lot of times we're reactive, and IPM is proactive in the sense that it is aware of the pest organism, tracks the population, and then at some point, based on those population density estimates, we make a decision. What are we going to do? And so here's your threshold. So in urban systems, the threshold may be very, very low. You guys working in landscape systems, the thresholds may be much higher. So, for instance, ants, you can tolerate much more in the landscape than you can in the kitchen, Or if we're working with a public health pest like German cockroaches or bed bugs, the threshold goes so low that it's really 1. You detect 1 cockroach in the structure you're managing, you need to do something, okay? So the threshold is really dependent on the environment and the pest that you're managing. Also, we use multiple tactics. So I'm going to talk about that today with these cockroaches. You never rely on one tactic in IPM. It doesn't matter if it's non-chemical, it doesn't matter if it's reduced risk pesticide. If you're relying on one thing, you're not integrating. You can't integrate one thing. So you have to have several tactics that are working in a way that they don't interfere with one another. That's the integration. And then, of course, at the end, we evaluate the program. So hopefully everybody that's managing pests, you guys have records that you keep, not only of the materials that you apply, but of the activities, your monitoring activities, monitoring data. That's a hallmark of IPM, and then, of course, that feeds back into education. So anyway, this is the requisite IPM soapbox component of this talk. We're going to move on. Questions about the IPM process? Excellent. You guys are all practitioners, so you could probably give this part here. And actually, when you do have your public fora, it's excellent, I think, to talk about the IPM process, all right? We're not choosing material A over material B. That's not IPM. There's a whole process here, and sometimes the public doesn't understand that. So I think it's valuable, whether you're managing weeds or cockroaches, to understand this process. Okay, so let's get to the subject at hand. Outdoor cockroaches, and again, I'm talking about these large, scary species. They're highly dependent on moisture. You find them in the environment, out in the landscape. They are omnivorous. So anything that is decaying, whether it's vegetation, animal matter, they can use that as a food source. And these species I'm going to talk about today, you can typically find in areas that retain moisture, such as in-ground utility ports, water meter boxes, pavement voids. Sometimes you have hardscape features with expansion joints that have long rotted away, and you've got a void space in there that's perfect for development of these cockroach species. What's interesting, and maybe you guys don't encounter this in the same way in San Francisco, but all you got to do is go inland a little bit, and you see this remarkable dry down that occurs in the landscape as it gets hot, and the moisture starts disappearing in the landscape. Lots of critters are seeking out that moisture late summer and fall. And so what tends to happen with these large cockroaches is their populations are, fat and happy, so to speak, in the moist, cool season. And then as it gets dry and hot, they're looking around for water. And a lot of times that's when we see these invasions into structures. And that's just part of their ecology. So what are we talking about here? The original character, the OG of the blatta in California is this Oriental cockroach. Very common, especially in the northern parts of the state, the cooler parts of the state. Sometimes people call them water bugs in California. I'm not sure why. I come from Florida, and we have different things there called water bugs. They're actually water bugs. It's a piercing, sucking mouth part, and it'll bite you. So cockroaches are cockroaches. They're not beetles, they're not bugs, but for some reason people call them water bugs. That's fine. It kind of describes their habitat. They're associated with moisture in the landscape. The cool thing about these blatta species, they cannot climb slick surfaces. Many cockroaches can. So if you have German cockroaches indoors, you have American cockroaches in the sewers, they can climb whatever. They're great climbers. But this genus has trouble. So sometimes they get inside and they may fall into something like, let's say, a bathtub or a sink. They won't be able to get out, but we can use this attribute to catch them in the landscape. So I'll show you how we build a trap to do that. So anyway, this is the common one. Show of hands, you guys familiar with this species? A couple of us. And maybe in some of the warmer parts of San Francisco and the peninsula, you will find this species. Yeah. So, but now we have a new character in the landscape. All right. So this is the Turkestan cockroach, same genus. So it's closely related to the Oriental cockroach. Same ecology. All right. Still going to be in the landscape. Still going to be associated with moist environments protected from the sun. Still going to search out moisture in the dry season. So everything's the same. The difference is the appearance. And we've had a lot of misidentifications, especially with the male. So the male's the one in the middle here. He's kind of a blonde, right? So the Oriental cockroach, the male is in the lower left here. They have reduced wings, but still very dark brown, almost black, whereas the Turkestan, fully formed wings. He's a blondie, all right? So we do have folks who will mistake these male Turkestan cockroaches for American cockroaches, which are another big scary species that largely lives in subterranean areas, sewers, boiler access, storm drain access. You will see them. Oakland, San Jose, we have them. And then, of course, the females look almost identical to the Oriental cockroach. Here's some glamour shots of this species here. So you have the female on the left, you have the nymph on the top right, and here's the blonde male. So this is a photographer, Joyce Gross, who captured these images. I also have some resin mounts of this species. I told Jessie and I was going to bring cockroaches. She asked me before the presentation, are they alive? So anyway, this will give you a good look at what these guys look like. Where did they come from? We have a couple, well, we know where they came from. We have a couple hypotheses about how they got here, okay? So this species is native to the Middle East. It's quickly becoming very common in Southern California, and that's been a question. How did they get here? One hypothesis on the top left, you see some military equipment. For decades now, the United States has had military installments in the Middle East, and that equipment doesn't live there forever. It comes back, and it gets housed at military bases. So cockroaches can climb up inside equipment, and they can deposit their egg cases inside the equipment. So that's one hypothesis, is that these cockroaches hitchhiked on military equipment. And in fact, if you look at some of the first infestations in California, they are associated with military bases. So that's one hypothesis. The other, on the top right, you see kind of an egg carton, like maybe you guys feed reptiles and you go buy crickets or something like that. You can buy these guys online, and reptile enthusiasts call them red runners because the nymphs are kind of reddish. Remember, they can't climb slick surfaces, so it's ideal to dump them in a terrarium and you got your lizard in there or whatever. These roaches cannot climb out. So it's an excellent food source. There's no paperwork or anything required. You know, the internet's Wild West. You can go on and you can buy these guys and they'll show up at your house, and they could potentially escape. They could potentially be released, and this environment ecosystem is similar enough to their native habitat that they have survived. So those are two hypotheses. Maybe both have occurred, but this species is quickly becoming the most common, especially in the warmer areas of the state. So where am I talking about? So probably for like 15 years, it's been known from Southern California, especially the desert regions. I have a colleague in Arizona. I have a colleague in New Mexico. It's the only species they see. But over the past 10 years, the population has been increasing up the San Joaquin Valley, and especially during our drought years. And I'll explain why that may be in a second here. And then, of course, recently we have these isolated populations being detected at places in Northern California. San Jose has a confirmed infestation as of 2017. Why is it displacing Oriental cockroach? And remember, Oriental cockroach has been here for decades and decades, and long enough for us to have these colloquial names like water bugs for them, right? So not only does it develop more quickly, okay, so from egg to adult, it's 250 days, where the Oriental cockroach requires more than a year, all right? It also produces more eggs. So, these ootheca, these egg cases, have 16 to 18 eggs within them. So that's not one egg, that's like a pack of eggs, a carton of eggs perhaps. And so they produce more than twice the number of the Oriental cockroach during their lifetime. So, they develop more quickly, they produce more eggs, but here's the important one. If you look at this last bullet, they have been shown to exhibit decreased cuticular water loss. So in a dry environment, they lose less water to the air, okay? So during the drought years, there may have been cases where the Oriental cockroach was not able to survive, and this species was able to displace it in some of the drier and hotter areas of the state. How do you tell the difference? So the Oriental cockroach is on the right, Turkestan on the left. There's two ways. The easiest way is to look for the pale stripes that are lateral, these lateral kind of cream stripes on the Turkestan female on the wing buds. But in some dark individuals, it's not always clearly visible. So the surefire way to tell the difference, you look at the space between the wing buds on the thorax. And if you guys are still looking at these, you can kind of look at what I'm talking about. But there's a space that's visible between the wing buds. And in the Oriental cockroach, that space is wider than the width of a wing bud itself. In the Turkestan cockroach, it's actually narrower than the width of an individual wing bud. All right, and you're saying, how am I going to see that? It's actually pretty clear. Maybe on this image, you can kind of see what I'm talking about. Yes. So this space right here, so the wing bud, I'm outlining a wing bud. It may be easier to see for folks who are up front. And so the width here is right there. The width between the wing buds is all of this. So the Oriental has a very broad thorax. The males are easy to tell apart. And in fact, what you have to worry about the most is mistaking the males for American cockroaches. And you can do that by the size. American cockroaches are much larger. Also, American cockroach on the pronotum has kind of a gold bar that is on the distal kind of posterior margin of the pronotum. I think I have a photo of an American cockroach coming up. I'll show you what I'm talking about. And then, of course, between the Oriental and Turkestan, they look very different. The nymphs are very difficult to tell apart. The Turkestans tend to have more red, especially in the legs and the thorax. So if all you're catching is nymphs and they're really red, more red than you've seen in the past, you could be dealing with Turkestan. And so here's what I mentioned here. The American cockroach, around here, you're only going to find it in warm, humid, subterranean areas, which, if you're in a city environment. If you're in a zoo, well, all bets are off. These guys are associated with animal husbandry. I don't know who does your pest management here at the zoo, but maybe you have this species here. And you remember I talked about the kind of gold ring towards the posterior part of the pronotum on that species. You won't see that on the Turkestan. And of course, these guys are huge, up to 2 inches, and they fly if they're warm enough. So again, I grew up in Florida. These suckers, sometimes they're climbing up the wall, and it seems like they always fly right at you, especially if you got a white t-shirt. It's like, they want to land right there. Well, you guys had the Australian cockroach that you were dealing with in the conservatory flowers. Maybe some of you folks have seen. That's another species of Periplanata. It looks very similar. And that one was flying into people's champagne glasses and wedding cakes and stuff, right? So then, of course, in Southern California, we have this another Periplanata species. You won't see it up here. And this is a landscape species that you'll find living in like railroad ties or timbers that are used for landscape edging. It also likes to climb. So you see this one sometimes in the attic, where a lot of the Periplanata are going to tend to stay low. And certainly the Oriental and Turkestans are going to stay low in the environment. Okay, so now we have a new player, and this one's little and cute, but also an outdoor cockroach. So this one's called the three-lined cockroach, and I have a resin mount of this one I'm going to pass around. The reason I'm showing you this one is because it also lives outdoors, and it has the same ecology as the Turkestan and Oriental as far as being a detritivore, eating decomposing organic matter, and seeking water in the late season, when it's dry season. So that means they can get into structures. The problem with this guy is you can actually mistake the adults for German cockroach nymphs. So German cockroach nymphs, they have two black bars on the thorax, right? And sometimes extending onto the abdomen. These guys have three, but they look similar enough. If you haven't seen it before, you could think you have a German cockroach problem when you find this indoors. So they're very small. This is an adult female, and they're only going to get less than 10 millimeters long. So they're tiny. They're native to the Mediterranean, and right now we think they're restricted basically to the North Bay and other parts of the bay. So it's kind of like our cockroach. This is ours, all right? This one, I guarantee you have in San Francisco. I haven't collected it from San Francisco, but the environment here is what it prefers. And you will see it in the landscape. So all of you guys that are, with your nose in the ground doing landscape activities, you may see these cockroaches skittling around. We've collected them from the East Bay, a lot in the North Bay. The first record is from Marin County in California. I've collected them from Mendocino County, but that's it. So the researchers that I work with in Riverside, they're always after me to send this cockroach down because they don't have it, and they want to try to raise it and try to understand its biology. So this is ours. Very small, just like German cockroach, the female will carry the ootheca around a little bit, but the difference, of course, you got three lines here, but it's green. And Carlos is not here, but Carlos and I did some collections. I'm talking about a gentleman that works with Pestec, Luis's brother. And we saw a bunch of females carrying these ootheca around. They're beautiful. It's like a jade green color. But then, of course, when they drop it, it turns brown. Really small. Okay, any questions about this one before I move on to management? Yes, sir?
I think that we have that in Sebastopol associated with orchards.
Absolutely. Yeah. Yeah, the North Bay is they're tiny. The North Bay is the hot spot for those guys.
Do they pose anything besides the visual nuisance?
Yeah, I think it's a mistaken identity problem. So if you're out in an orchard or vineyard, they're not going to be considered a pest. But if you have an orchard or vineyard next to a structure, and then in the late summer they get into that structure, and people say, we got cockroaches, it could drive unnecessary pesticide applications in the structure. Yeah. Okay, so how do we manage outdoor cockroaches? Remember, prevention comes first when we're using IPM. So with cockroaches, we know that they need moisture, so we can try to reduce available moisture in the landscape. We can try to modify the habitat. We know that they live and breed in these protected spaces. So I mentioned the missing expansion joints that lead to pavement voids. You could have hundreds or thousands of cockroaches in here living, and it's difficult to get to them, but that's where they are. And then, of course, they're going to come out and forage from there. I think if you're talking about structural pest management, exclusion is really important. So something as simple as a door sweep. that seals that gap between the door and the ground, can prevent these suckers from coming under and getting into your structure, all right? Other times there are other ways, other structural defects that allow these guys to come in. So this image here, maybe it's tough to see, but this is at a school where I was working, and I caught them in the act. So we would do night surveys to try to understand the pressure. And this is a photo of, there's a female Turkestan cockroach, there's a male, probably interested more in the female, but the female's going right under the door, because you had about a 3/4 inch gap. So that's what they do. They live in areas like this, and they cause problems because your structure's not sealed up. So what's the threshold? This is kind of debatable for this animal. Out in the landscape, they are detritivores. They're helping to break down this decomposing matter. Indoors, the threshold may go down to the point where I don't want to see any of them. So maybe the threshold is 1. This depends on your situation. It could be that you do a good enough job excluding cockroaches that you don't care if you have a population outside, all right? They're feeding things like birds, lizards, rats. Maybe you don't want to feed the rats, but the rats will eat them. So they're part of the ecosystem. But let's say you do all that exclusion and you still have problems. If you're going to take action within IPM and you're considering chemical tactics, what's available? We know with German cockroaches that baits are very effective. And we'll talk why in a second. Why are baits very effective? In an outdoor environment, the question is, how's the bait going to stand up? Especially if you're using something like gel. We know cockroaches really like to eat the gel baits, but in a landscape, especially if you're in an area like San Jose or even the valley, it gets hot, it gets dry, and the water is evaporated from that gel matrix. It quickly becomes rock hard. So the common thinking is that, cockroaches aren't going to be attracted to these gels outside. You also have granules. Now, the traditional treatment for these kinds of cockroaches has been what we call liquid barriers, or perimeter protection. And basically you're putting down a deposit of insecticide that's the insect will pick up on its way in, and it will pick up a lethal dose. So let me ask you, does that control the cockroaches living deep in the void space? No. Let me ask you another question. Does it stop the cockroach from getting inside? No. So now instead of having a live cockroach running around inside, you got a dead cockroach inside. That still can lead to pesticide applications inside. People that don't understand the ecology, they're like, you got cockroaches in here, all right? So the perimeter protection programs, they've been in place for decades. Some people say that they work very well for Oriental cockroaches. I think that's debatable. With the Turkestan cockroach, people's programs are failing left and right. They're not able to keep cockroaches under control. They're not able to keep them out of the structures. So my research aimed to develop a new program to try to really attack these guys and manage the population. I mentioned that we have surface water contamination issues. So some of those liquids that are used in the perimeter protection are actually regulated by the state, and you can't apply them to impervious surfaces certain distances away from the structure. There's a material called fipronil, Thermador, or Taurus, and that material can't even be applied during certain parts of the year because of the potential for runoff. So these regulations are increasing and really pushing folks away from these traditional perimeter protection programs. But they also don't work, okay? Because of the reasons I just discussed, but also because of insecticide resistance. If you are using a similar class of insecticides over and over and over again, you're basically selecting for resistant individuals that will reproduce, and eventually you have a resistant population. So most of the perimeter materials are pyrethroid insecticides. And I worked at a school site where they didn't have control, and I asked the gentleman, can I see your use records? What have you been using in your program? And he says, I don't know what's going on. I've been rotating my products, and which is great for resistance management. You want to rotate between chemical classes. When I looked at his use records, he was actually rotating different pyrethroid products. So it's the same class of insecticide, but different pyrethroid active ingredients. And so I think what was happening is basically selecting for a resistant population there. They were making 1 or 2 applications a month, for 4 years, and the population kept increasing. So you have insecticide resistance issues. Places like schools, hospitals, college campuses, somebody mentioned they're here from UCSF, you are going to have certain protocols and sometimes actual legislation that requires you're not going to be able to do those perimeter protection programs. I'll skip this, but basically I was given money by the Pest Management Foundation to look at baits. So we started in the lab, and I worked with Professor Mike Russ down at Riverside. And what we did is we looked at 5 different bait products that are commercially available. This is a standard bioassay. It's like a plastic container. You throw a cohort of cockroaches in there. You got some males, you get some females, you get some nymphs, and you expose them to 1 gram of bait, but you also give them a food source. This is dog food, just like a dry kibble. And so it's not like they have no choice. They can eat that dog food if they don't want the bait. And so we looked at the fresh bait. So let's say it's gel, it's right out of the container, but we also looked at dried deposits of bait. It says 7 days here, but we actually took that out to 14 days aged in a low humidity environment. So if you've ever worked with any of these gels, you put it out into a low humidity environment like most office spaces or something, and within 3-4 days it's rock hard because it loses so much water to the environment. So we wanted to see what happens when we actually offer from day one rock hard bait. Do the roaches still feed on it? Do they still die? And this is a busy graph, but pay attention to the height of these bars. The top is 100% mortality, and this was measured after 14 days of basically roaches living in this little environment. And the takeaway here is that all the baits work. And not only do they work as fresh deposits, but they work as dried deposits. So the ones, let's see, here you go. So the yellow, blue, and green, and I know there's several blues. I'm colorblind, so sometimes I have trouble with these. I try to pick contrasting colors. But basically all the bars, at the last 3 bars in the clusters are the aged bait. So it didn't matter. It didn't matter if it was fresh or aged up to 14 days. We still killed 100% in most cases of these cockroaches. So, and this is just a summary here. Everything was effective. The baits were effective, fresh or aged. We did do some measurement of feeding. So we measured the mass of those bait deposits before and after, and then we had an evaporation check as well, so that we could try to calculate how much the roaches actually ate. And we're talking like hundredths of a gram, sometimes thousandths of a gram, tiny bits. But what we discovered is some of the products, they don't even eat that much, but they handle the bait. They antennate the bait. And the cockroaches, they groom themselves. They're actually, you can say they're pretty clean because they're grooming themselves all the time with their mouth. So their legs and their antennae, they're cleaning it off with their mouth all the time. And so we think what happened is just the contact with these bait deposits was enough to have a residue on their body parts that were then cleaned. But whatever the case was, we killed all the roaches in the lab. So we wanted to take that idea out to the field. How am I doing on time, Chris? I don't want to. Okay. So we want to take this out to the field, and so this was a project working with California Department of Pesticide Regulation in schools. And remember I mentioned that in schools we have regulations that actually make it difficult to just broadcast spray into the environment, or even the perimeter sprays that I'm talking about. Those would require what's called notification, posting, and special reporting. So the notification might be the most difficult part of that. You basically have to notify all the parents, all the staff who are interested in knowing about pesticides being sprayed in that campus environment ahead of time. I forget how many days ahead of time. Maybe Luis knows. Yeah. It's a long time. Yeah. It's at least 3 days, maybe longer. Anyway, so you have to notify them. You have to put up, the posting is, I think it's 24 hours ahead of time and then 72 hours after. So if you were going to make a perimeter spray around a building, you would have to physically go, you put a sign, and that's 24 hours ahead of the application, and it has to stay there for 72 hours after the application. That's like a kind of an awareness regulation, kind of a right to know for the parents and staff on that campus. But of course, it can lead to a lot of questions. It can lead to a lot of engagement, let's say, with the community. So people, professionals working in school environments, they're looking for ways to avoid this hassle or additional labor. And so I thought this is a great place to demonstrate the BAIT program. BAIT only. And so in schools, you can get around these notification and posting requirements if you use baits that are in self-contained, tamper-proof stations. So they're lock and key, and nobody can get in them. And the only way that that insecticide leaves is within the body of the animal. So if you do that, you don't have to do all of these notification and posting requirements. So I thought this is great. We can do a demonstration here. We first started at a school in Mendocino County, Ukiah High School. And remember I showed you that map that had like isolated populations of Turkestan cockroach? One of those stars was in Ukiah. And you wonder, how did they get up there? The school district had borrowed equipment from another district further south to renovate their football field. So just like we have military equipment that moved from the Middle East and now the cockroaches are here, this district borrowed equipment and brought cockroaches to their campus, and it was an isolated population, huge. This is the one that I'm saying for 4 years the population kept increasing despite the huge number of pesticide applications that were being made. The community was outraged. They created a Facebook group called Eradicate the Cockroaches from Ukiah High School. Quick question, is this a Turkestan cockroach? It's some kind of periplanata. It looks to me like Australian cockroach, but you see this yellow bar on the bottom of the pronotum. So they use this photo. But anyway, eradicate the cockroaches. Yeah, they got their ID wrong. What do those Ukians know? So they have this Facebook group, and there were 6,000 members of the Facebook group. Ukiah only has 16,000 people there. So you're talking, over a third of the population is part of this group. And they were posting things like, the school's not doing anything. Let's go in the middle of the night and make our own applications. And they actually did it. We would find, strange white powders and, people were saying, the school doesn't know what they're doing. We need to protect our children because the cockroaches are coming home in children's backpacks. And, we go to the football game and we're stepping on cockroaches. And people were furious. So I thought it was a great environment to demonstrate my program. This is the density. These are all Oophaca. Remember how many eggs I told you are in each one of these? 16 to 18 with this species. So each one of these little oval shapes has 16 baby cockroaches that are going to hatch out. And this was just the density that we found under a grease barrel that was next to the kitchen, sitting on dirt. So you move the grease barrel, and there probably were 1,000 of these Ootheca. So that's 16,000 nymphs that would be resulting from that. So great challenge for us. What we did is IPM. We started with structural exclusion. Let's see if we can close up those gaps where they're breeding. Let's see if we can put door sweeps and keep them out of the buildings. Then we went to baiting, and we looked at 3 different bait products. We used a granular product, and we used gels in different environments. And then I worked with the pest control operator because he is a one-man show, kind of old school, and he said, hey, if you do this baiting program, how am I going to make a living? And so I explained to him, you know, there are other applications that you could make. Before the school has a chance to seal up all these void spaces, you can actually make foam applications. So remember I showed you those cracks where you had the roaches going in and out? You can actually make a foam insecticide application that will penetrate and fill that void space and try to knock out the breeding population there. So he was doing that when the school wasn't able to seal those quite yet, you know, because it takes time. You know, this is a huge campus and they're trying to seal all of those gaps. So this was the program, an integrated program, I would say. So the hardscape sealing, they played around with lots of different materials. Some of them worked very well. This was a success story. I forget what this compound was, but I've been back a couple years later. It looks great. Some of the expanding foams, some of the other sealants didn't work out so well, so it was kind of like a laboratory for different sealants, which is great. And I need to touch base with the maintenance and operation director up there to learn, because I think a lot of us doing exclusion work have those questions. What's the best material for this particular application? We don't know in a lot of cases. They also did a really neat thing here. They put the trash cans all on pedestals. It's tough to see here, but there's like a little pedestal that keeps the trash can like 6 inches above the ground. And so this eliminates the hiding space that cockroaches would use where it's moist, there may be food. So it was a neat thing that they did. I think it also made it tougher for the rodents to access the trash cans and ants. So this is our baiting program. We use self-contained stations. So this is actually a rodent bait station. It's kind of triangular. It's for mice. It's meant to fit into a corner. And I love these kinds of things because really what it is, it's a lock and key box that you can put anything in there. If you're managing rodents, you don't have to put bait. You could actually put a snap trap in there, you know. And with cockroaches or ants, you can deploy liquids, you can deploy gels, granules, and it keeps it lock and key so it's complying with the regulations, and the animals will find it, you know. So we use these, we apply gel directly in there. I also, I think I invented this application, I don't know. I'm calling it the bait combo. You remember those snacks? It's like a pretzel with cheese inside. So a colleague of mine in Virginia, she uses wax paper and she puts bait in there and rolls it up, and she calls them bait burritos. So I thought, all right, well, this is a bait combo, because what we did is we used PVC slip couplings, and you make the bait application inside, and then you could drop those down into the utility ports, other in-ground boxes. And the cool thing is, number one, the professional could actually fill these bait combos up in the shop, put them in a bag, and then go out to the field, and it's really quick to just drop them in. And then number two, you can actually see if the bait's been consumed. If you're applying, like a traditional application might be like a gel under the lid here or in a crack, and sometimes it's difficult to tell if there's been any activity. So anyway, we did that, and we used these 3 products, 2 different gels, and a granule. And so at the school, this is a huge school. If you look at the scale here, 50 meters. We tried to establish treatment areas that we thought were going to be independent from one another. You know, as a researcher, you're like, oh, you don't want one treatment area to affect another. And so we didn't know what the size would need to be for that. We looked to the literature to try to figure out the foraging range of these cockroaches. There's nothing out there. So I looked at another large outdoor species that lives in landscapes. Remember the smoky brown cockroach that I said lives in the railroad ties and timbers? There was some studies from Alabama, Mississippi area calculating how far they go from their harborage. So the harborage where they go, to rest during the day, and then they leave from there to forage. And so they had estimated it was about 100 feet maximum that they were moving from that harborage area. So we used that figure to establish these treatment areas with the hope that they would be independent. The cool thing is the school let me do an untreated control. So these are the black circles, and usually if you're managing urban pests and you're doing research, they don't want any untreated controls. They say kill them all. So then basically you end up comparing one insecticide to another. In this case, I got to see whether the insecticides were better than nothing at all, which is great control research. The cockroach pressure was immense. We were monitoring using glue boards, and so, or sticky traps, I should say. This product is called Low Line. It's made by B&G. Maybe it's called Low Profile now. I think they changed the branding recently. A lot of times people use these indoors to try to figure out where the cockroaches are getting in. We actually use them outdoors to try to figure out where the pressure was highest, because we know they're outside. They're running around outside. The problem is this is a high-use area. It's a school. So what we would do is we would wait until after swim practice, and we would go in the evening, and we would set these glue traps near exterior doors in our treatment areas. Every treatment area had these deployed, and then you'd have to go in the morning to pick them up before the kids get there. Well, some kids got band practice, and you got remedial tutorial work, and so you'd have to be there at 5 in the morning, 5:30 in the morning, and pick up these traps. But this is just an overnight period. So the activity period for this species is temperature dependent, and they're nocturnal. So they're not going to come out until 10 p.m. And they're only going to be running around till maybe 2 a.m. Then it gets a little cold for them and they go back to their harborage. So this is probably about 4 hours of activity near the exterior door. So if you had a gap under the door, how many cockroaches might get in? Huge numbers. We also used jar traps. Remember I told you that these can't climb slick surfaces. So we deployed these mason jars. You wrap the jars with masking tape, and then you bait them. And so we would use bread, little 1-inch squares of bread, gently soaked in beer. You're any choice. And I've got this question: what's the brand that works best? And it doesn't matter. So my staff researcher, she got to pick the beer. I don't drink, but she would always pick, and she would get nice IPAs sometimes. Other times she'd want a lager. Didn't matter. So you just dip the bread in the beer just to get it wet. That's in the jar, and the cockroaches will climb up, and then they fall in. They can't get out. So this is what we would find in the morning. And we used these live collections to establish colonies in the laboratories that we work with, so that they could try to measure things like insecticide resistance or any behavioral differences with other populations of Turkestan cockroaches. So actually, remember I said that 2017 we found this species in Santa Clara County. I worked with vector control down there, and they said, yeah, we're having weird problems with cockroaches that we haven't had before. And I said, well, maybe you got Turkestan. And they said, well, how do I know? Because these are nocturnal, and I got to go home and spend time with my family at night. And I talked to them about building these traps. So the biologist down there, she did it one night, and the very next morning she was able to confirm that they had Turkestan cockroaches at that site. So it's a very effective trapping method. Here's what we found through that baiting program. This is a 1-year time period, all right? And basically, we killed a bunch of cockroaches right away. Within a month, the population was significantly reduced. Within 2 months, we had trouble finding cockroaches. The problem here for a researcher is that this gray line, or I'm sorry, the blue line here, that's my untreated control. So I also killed all the cockroaches in the untreated control. And so the school was very happy, but I was wondering what happened here because, 5 minutes?
No, I was going to say, how do you know you killed those?
Good question. My observation was that they all declined in all treatment areas. So then you start to ask that question, why did the cockroaches in my untreated areas also disappear? All right? And the experiment was not designed to measure that or answer that question. Matter of fact, this shows me that the experiment had some issues, the way it was designed. So one thing we know about cockroaches, they are cannibalistic. So when you use bait in an apartment building for German cockroaches, you're killing not just the cockroach that eats the bait, she or he is going to die, and then his or her buddies are going to eat them, and they're going to die, and sometimes they get eaten and they're going to die. And it's because the toxin is persistent enough in the body tissues of that cockroach that you get secondary and even tertiary mortality. That's why baits work so good with cockroaches. So this is a sticky card, and here's a male that got trapped near the edge of the glue. You see the glue right here at the bottom of the image. And so his comrades ate him while he was stuck. He was probably alive while they were feeding on him because they didn't need his head, so his brain got to process all of this. Anyway, so if you get this secondary and tertiary mortality, well then remember we talked about foraging range. Foraging range comes into question because if a cockroach that was baited traveled more than 100 feet away, all of a sudden it's affecting another treatment area.
I have a question. You said that cockroaches are food for other things, rats and lizards and stuff. Are any of these actives toxic to those animals?
There's secondary kills within the cockroach population.
Yeah.
Does it extend to other species?
So the insecticides used here are designed to interfere with the metabolism of insects. However, there's a lot of unknowns when you're talking about pesticides. And I don't know.
So boric acid powder in Harris cockroach, which is for consumers and homeowners, that's not toxic to larger animals because of the small dose, but it continues to kill cockroaches?
Well, boric acid is a stomach poison. It's not as persistent as some of these insecticides, so you might not get as much of that secondary kill, if any. The baits that are used indoors, you've got fipronil, which is very toxic and very persistent. You've got neonicotinoids in some of these baits, indoxacarb. So these baits are persistent. It's a great question. It's never been observed to affect these kinds of predators of cockroaches, but I don't know if anyone's designed an experiment like that. The thought is that these are insecticides designed for the insect metabolism, but and I think you guys all understand this message, we don't know. And with pesticides, it's kind of scary because acute toxicity and hazard from the EPA. And that's why we have the community upset because we don't always know what the chronic hazard is. And most UC researchers are not going to talk to you about that, but I recognize that's an issue. All I'll say is that these toxins have been designed with the insect metabolism in mind. So they're not broad spectrum in the sense that they're going to affect vertebrates. During the acute health and safety, there are tests that the EPA does to see what the vertebrate toxicity may be. So, I'm not a toxicologist, but
I can add to that a little bit. I mean, we have a very simple hazard screen that we use that does look at some of the chronic effects, the tier 1, 2, 3, as an effort to get closer to that. And you'll come out with a tier 2 or tier 3 for a lot of these products, but there's still that data gap. There's always a data
Sure.
gap. So we don't really know
Yeah.
for sure.
I mean, we can trust EPA. We can try to trust EPA about acute health and safety measurements, and so this really does represent an acute event. If a cockroach dies and then it was eaten by a rat or it was eaten by a bird, that's an acute event. So that's like one-time dose. Is it toxic to that vertebrate animal? And so there have been health and safety tests at the EPA level to answer those questions in order to register the product. But you know, every organism is different. And in model organisms, it's always kind of tricky. So I'll just not answer your question because there's no way to answer your question. But yes, it's worth considering all the toxins in our environment and how they may interact with the ecosystem. And the scary thing is we don't know. A lot of times we don't know. But in this case, we killed a bunch of cockroaches. I know that. So we also did a study in Riverside County. So I'll end talking about the Mendocino County study with this problem, this experimental problem. Our controls died, all right? Riverside, we had a smaller population, lower density, and it wasn't a nuclear issue like it was in Ukiah. You didn't have the community up in arms, but you certainly had cockroaches getting into classrooms. You had teachers bringing RAID to school, making their own applications. Very common, you know. You guys are getting excited about that, but it's very common. If you work in schools or multi-unit housing for that matter, when there's a pest problem, the people sometimes take matters into their own hands and they're bringing materials in and liberally applying them. So we did the same thing there. This is just an image of my mouse bait station. In this case, we use 3 small placements of bait. This one was totally consumed. This one was partially consumed. You have a dead female right there. So some entomologists would say, how do you know the roaches are going to use the mouse bait stations? They're not mice. Actually, the entomologists don't say that. General public often will say that. But the roaches go in, no problem. They eat the bait. They don't care that it's for mice. So in Riverside, we actually were able to show control from an experimental standpoint. This blue bar is the untreated units, and we used the same design. So it was the same size treatment areas. What we think happened is with the lower density, there was a smaller foraging range. So lower density of animals, they have more food, they have less reason to be spreading out so far. But this worked beautifully. You know, this is what you hope your control experiments will look like. So what did we find in the field? We were successful. Exclusion was successful. Baits worked well. The foams were a great way to keep the pest control operator in business, but work with us rather than against us. He had a mortgage to pay. The whole population crashed, suggesting that the foraging ranges may be very large for this species. Overall, these are the messages if you're managing these cockroaches. Bait-only programs work very well. Doesn't matter if the bait is dried. It doesn't matter if it's gel or granule. As long as you put the bait out there close to where the cockroaches are living, breeding, or foraging, they're going to find it. You're going to kill them. So especially if you're working in areas like schools or other sensitive sites, this represents an alternative to the liquid sprays that I think should really be considered by professionals out there. So I'll wrap up with this. This is Google Maps of the high school, Ukiah High School, all right? So here's the football field where they did the renovations. It's kind of the epicenter of the infestation. This is the area that I eradicated here in Central Campus. But you see adjacent to this football field, you have a suburban neighborhood. Down here, this is actually cemetery, where you see all these trees. What do you have in cemeteries? Well, you got corpses, of course, but hardscape with missing expansion joints, lots of places for cockroaches to hide. So we killed the cockroaches here, but you can definitely have populations that will persist in this suburban environment and in this kind of landscape environment. And sure enough, I've been monitoring this the Facebook group, Eradicate the Cockroaches from Ukiah High School. This is an image taken from someone who lives in that suburban neighborhood adjacent to the high school. They're catching cockroaches in that neighborhood. I didn't do any baiting there. So what's going to happen is if the high school does not maintain their program, you're going to have recolonization. So this kind of pest management, especially with an animal that forages so widely, really is a community endeavor. Or if you have that pressure from outside, it's a never-ending program to really monitor and treat once you detect the pest. So these are the collaborators, and I have some, well, I shouldn't skip so quickly through that. A lot of folks in Riverside, a lot of folks with Cooperative Extension, and made possible by National Pest Management Association and DPR. Very exciting and successful project. Contact information for me, and thank you for listening.